Traditionally, the way we navigate with spacecraft in deep space is we send a signal from the Earth, goes all the way out to the spacecraft where it's turned around and then rebroadcast back to the Earth. And we're measuring changes in the amount of time that it takes that signal to go from the Earth to the spacecraft and back again in order to determine where the spacecraft is and where it's headed to make sure that it will get to its destination successfully. What the Deep Space Atomic Clock would allow is for us to have a very, very stable frequency source on board the spacecraft. So now we could send the signals from the Earth to the spacecraft and do the navigation on board, or we could send a signal simply from the spacecraft to the Earth and then cut out half of that signal. Once we get this clock in space and we demonstrate its capability in space, I'm excited to see what we can do with it next. As the navigator, as the person who will in the end be benefiting from this clock, it really can make my job easier in a lot of ways. I can get more data, I can get higher quality data.
Traditionally, when we navigate in deep space, we use atomic clocks, but we use them on the ground in the tracking stations that we use to determine the position of the spacecraft in space. DSAC, the Deep Space Atomic Clock, takes the technology we have in our ground atomic clocks and packages it up into a small spacecraft-ready size of device. And we believe is going to be able to deliver the same kind of precision and accuracy that we get on the ground today. And so that will open up new ways in which we can navigate in deep space. For future human exploration of the solar system, I think that's going to be critical to making it safer and more robust to get out there and explore.